And welcome to this video where we will be now continuing our journey from the simple quantum circuit to look into some of the more specialized gate uh, to understand their behavior and how they manifest themselves. It is important to understand these gates that we will discuss in order to make more complex circuit, but still be able to figure out how the information is being interplayed, how the information is being transported from input to output. So in this series, we will first start with what is known as a Hadamard gate, H gate in short, and what it represents is a simple matrix as you can see. So 1 by under root of 2 and a matrix of 1, 1, 1, minus 1. Now the important property that, as we have understood before, these matrices have to hold is that they must be unitary in nature to maintain the state composition, and you can try applying the definition of unitary to see whether this matrix is indeed unitary or not. If you do want to understand what is an unitary matrix, I suggest you to look at the video series on quantum linear algebra to make yourself familiar with the definition and the workings of unitary matrix. Now, since Hadamard a gate is a gate or which applies as an operator in the circuit, we would like to see this with an example as to how it works. If we, for example, apply this on an state 0. So what we see is now a combination of matrix and vector multiplication, and we want to see how this act out in terms of output that it will give. Now, when you apply this and go through the matrix vector multiplication, again for which if you do not know, you would have, my suggestion would be to look at the quantum linear algebra videos, but this is fairly easy to do. Once you do that, you will find to get an output like 1 by under root 2, 1 by 1. Now, if you look at this very closely and try to play a trick on the output, you would be surprised to see that this can also be written in the format of 0 state and the 1 state. Now, if you do the reverse engineering or the reverse calculation on this one, you will still end up getting 1 under root of 2 of vector 1, 1. So mathematically, we are still holding up the position. However, to decipher what is the output, when an Hadamard gate gets applied on a 0 state, you get a superimposed state of 0 and 1. So it is kind of doing very unintuitively from one state, it is creating a superimposed two states, so to say. Now, another fascinating point is that if we now see the application of Hadamard gate now on state 1, you would find something very interesting. Here, if you do the same steps as we did while applying Hadamard gate on state 0, you will find the negative sign appearing in the vector, which then can be written as, instead of addition, but subtraction. So Now, so to say, this is again a kind of a state that has been created. But while in the previous state, where when we applied Hadamard on 0, we have the positive, while applying on 1, the state comes out to be negative, or some sort of a phase shift that is being depicted here. However, if you see very closely, we can also apply Hadamard to the composite state as we have found in the output in the last two scenarios. And once we do that, if you look at this carefully, we can go back to the original state from where we started. So here, once we apply the combination of state 0 and 1 in sort of positive sense, we are getting state 0, which is the reverse of when we apply Hadamard on the state 0, and we get a superimposed state of 0 and 1. This can be very conveniently looked into as some sort of constructive and a destructive interference being played at the same time. So if you see, the upper circle represents where the phase, for example, getting added up, so adding to being constructive interference. However, the bottom circle represents that if you add 1 with -1, the phases, for example, are getting cancelled out, and you get what you call as a destructive interference. And you will get your input state back in a reverse order, as we have seen. So I hope you got the intuition for this gate, and it is one of the most highly used gates in quantum circuit. So it is highly advisable that you understand the working of it and play around manually if you find it difficult to just see and try to understand, that to play it manually and do the calculation to see that the input and output is that you are getting is what's how it has been explained. So thank you very much for listening. I'll stop here and I'll hope to see you in the next video. Thanks a lot.